Hello and welcome to All Things IDA. In this episode, I'm going to be covering choosers and how to use them in IDAPython. First, we'll go through the SDK, how they look like in C++. Then we'll describe what makes a chooser, how they manifest graphically, and then we'll delve into actual chooser example in IDAPython. Alright, so let's get started by covering choosers graphically without programming choosers. So where are choosers already in IDA? You may have been using choosers without knowing their technical names behind the scenes. So for example, function list in IDA is a chooser. We can actually access it through its own dedicated, as we'll see, non-modal view, which opens it in its own window. You can also access the same chooser via the modal dialog. So here we can say jump to function. This is the same component that we see here, but it's a modal version. So what makes a chooser? A chooser is simply a list view with a defined set of columns. So we can have arbitrary number of columns and arbitrary number of lines. That's the responsibility of the programmer. So the programmer would define what's the title, how many columns, and the elements. Now, if you successfully implement a chooser with your own data, you get for free a bunch of chooser functionality. So for example, if we populate our own chooser, whether it's the functions window or any other chooser window, we'll get those free features. So for example, we can do Alt T to start searching in the list. We can then, for example, let's say search for sub underscore, press enter, and then we can press Ctrl T to search next. We can do incremental search. For example, if we know the beginning name of an item in our chooser, we can just start typing. So here, for example, if I start typing underscore main, we can see here it is incrementally looking for it. So if I click away and press, for example, underscore underscore, and I can see the first occurrence of something that starts with underscore. Now if I press Control Enter, it will incrementally search for the next element starting with underscore underscore. So Control Enter, Control Enter. Other stuff we can get if we implement the chooser programmatically are the filters. So if we right click, for example, we can do some basic actions like editing, deleting, inserting, and so on. And also we get to filter. So here the filter as well. This is built into all choosers. So you just have to populate the choosers in for free. You get searching, you get filters, you get like how to filter stuff, regular expression, fuzzy matching, or even an advanced filter and what to include, what not to include in the list. So these are the things we can get for free when we implement a chooser. Okay, so let's look at choosers from programmatic point of view. This is what I have in front of me here is the kernwin.hpp header from the IDA SDK. As a programmer, if you're writing in C++, you would have to subclass chooser and implement a bunch of things. What makes a chooser really? If we look again at the choosers, so here is functions. So we can see, for example, let's move this here. And here, what makes a chooser? It has a flags. We'll take a look at flags. It requires to know how many columns do we have. It requires then an array of integer character widths for every column. So we can preset how big is every column and characters. That's the title. We can specify the title. We can specify the headers. The column is an array of strings. Additionally to constructing the chooser, just like that, we have a bunch of callbacks. Some are mandatory and some are optional. The mandatory ones, for example, here we can see we have some callbacks, but let's focus first on the mandatory ones. Um, they must be in the base class so if I don't see them here real quick, they are in the actual base class. So that's the base chooser, all the stuff, and we will get like mandatory things. For example, here inside the chooser, we have to implement, you see here is a pure virtual that dictates it's a mandatory callback. So once we subclass the chooser, we have to implement a mechanism to return how many elements. So that's the get count. We also have to implement get row. That's where we return a single row given the row number. And then a row by itself is made up of n columns, depending on how many columns we created our choosers with. Um, so these are mainly the most important mandatory callbacks. Now let's take a look at the Python implementation. So since this is C++ and it requires subclassing some methods and so on and so on, we took the liberty to rewrap and re-expose choosers in IDAPython differently. If you recall from previous episodes, I did cover introduction to IDAPython. I did cover wraps, py wraps. So if I go back to the IDAPython source code and IDAPython and py wraps, we will find the actual handwritten re-exposing of choosers through a different interface. In the py wraps folder in the IDAPython sources, we will see both py underscore kernwin choose and kernwin choose.cpp. Both the CPP part is what re-implements abstracts choosers, but what we really care about mainly for now is the Python counterpart. And that's where we can start to draw our initial documentation from. Although this is the lowest level documentation, if you don't want to look at the sources, you can get the same documentation online. If we go to the Hexrace website, go to support, click on documentation, we will see IDAPython manual. And so if we follow the manual, we can browse everything that I'm browsing, and I'm gonna be looking at the source level. We can browse it here since the contents of this web page is generated. So here if I look for shoes, I will find the implementation documentation. So that's basically the new class, uppercase C for shoes. That class is your responsibility in Python. If you extend this class, you get a chooser. So I'm gonna explore that in code, not in the documentation. So this is good. Once you know how it works, you can use the online documentation to quickly refresh your memory about arguments, even callbacks, and so on get size and so on. But I prefer to look at them in the actual source code. So looking at py kernwin choose.py, this is the handwritten chooser wrapper. So what we can see some flags that are carried over from the SDK, and we will go over those flags as they become relevant. But for now, looking at the sources, that's the constructor of the chooser class. You can see we can pass title, the columns, but since we kind of expose the APIs differently, we can use Python and its facilities. We can actually make the using choosers much more pleasant. So for example, for columns, we don't need two arguments. What are the column widths and what are the column names, as in the C++ version? We can, for example, ask the user in the documentation that API is designed such as you pass columns as an array of a list of lists. Every list item is a list of two items. The first item would be the actual column name, and the second item is the column width. Additionally, we can add a flag and associate that flag with the column. And those flags will dictate how IDA behaves to some degree. It gives a hint to IDA how to sort or even color some items for you for free based on the colon flags. So here, for example, we have uh, we can pass colons. We can pass here. We have first colon, a list of 2 items. Second colon, a list of 2 items. Apart from colons, we can pass flags. These flags control the behavior of the chooser. Pop-up names. So pop-up names, if we look at an existing chooser, so this also the functions, if you right click, we have delete and edit. These are default actions. We can control whether to inherit the default actions or not. We have 4 default actions that we can actually bring in and override to some degree, or we can add additional custom actions. But other elements like what is the icon of your chooser? We can specify a hard-coded icon index, or we can actually load a custom icon and pass the newly loaded custom icons as index, pass it as an argument to control the icon. And the icon of the chooser will basically show up here. Default selection, the index of the default, when we open the chooser, what would be the first selected item index? So we can control that programmatically. Width and height, we can also pass those and they will be respected in certain cases. Of course, if the chooser is floating, so if it's undocked, if we take this and move it like this, then the width and height will be respected. All right, so let's start with the actual chooser code. So to get started with the chooser, we want to inherit from the choose class, and then we need to implement the mandatory callbacks. So here we can see we have on init, it's not mandatory, so we can tell it is optional, but it gives us a chance to do some initialization. This happens when the chooser UI element is created internally. On get size, it is one of the mandatory ones. So here these are the get line and get size. Both are the minimal callbacks we have to use. Then optional stuff like you can even specify an icon per line. We can also override the attributes per line. In the chooser, we can have bold, italics, etc. We can have callbacks such as I want to insert line. So you press insert on the keyboard, you get a chance to act upon it. Maybe we can bring a dialog, ask the user to import some stuff. Delete line, we can give a user as well a chance to delete stuff from our chooser. So whatever you want to populate your chooser with, you can actually let the user edit, delete, insert, refresh, get line attributes, and even you can detect selection change if you want to make your chooser much selection sensitive. So as you scroll up or down, you can get a notification. We can also handle a selection. So when the user presses OK or enter, so here if we invoke a chooser, let's say jump by name, select something and press OK or enter, we get our select line callback. We can get notified on close if we want to flush stuff to disk, and so on and so on. There are other callbacks we will be talking about in future episodes. So let's switch to our code. So the first thing is I start the chooser by giving it a name, any name, but the most important thing is we have to inherit from choose. Since we inherit from choose, we control the constructor. We can put any arguments we want. We can have even 0 arguments, doesn't matter. Well, what matters is when we call the base constructor to pass the appropriate arguments. So here in this example, I'm calling init, passing a title, whatever the user wants to pass the title. I'm gonna hard code a bunch of columns. So let's add 3 columns. address of an entity name, and let's make something fictional, call it type. Type, it's the type of that element at the given address, and let's give it 8 characters width. So this controls our colons. When it comes to flags, the only flags I care about here is by default our class says 0. Don't even have to let the user pass the flags. But we pass the flags to the base to control certain aspects. Let's take a look at the flags now. So all the flags are with ch underscore. For example, ch restore lets the chooser, if we close it and if it was floating, to restore its size and location, for example. If we want to support directory widgets, we will enable that flag, but that's not for today. We can even disable sorting for that chooser. So I did not directly mention sorting, but if we go back to any chooser, if we press on the column name, we get the sorting. Address, any column can be sorted, and of course giving a hint to the column can help the sorting algorithm. So if we say this column is hex, that helps internally. And we can right click and unsort, so to stop the sorting here, unsort. So no sort, and so on. So for my case, I chose only one flag, restore flag. The rest, we can keep them by default if we wish. But that's basically the constructor. All we had to do is pass the title and the columns and the flags. Rest are fine default for now. Now these are not part of the chooser, but this is what I will be doing to actually implement the chooser. We'll talk about those in a second. A pop-up names is what lets you control the default actions and override their names. And it's a simple array which takes 4 elements. And let's also show you how and what they are. So we have 4 default actions that we can enable or disable. And we can also change their label. So when you build the chooser, if you override the pop-up names, which is an array of 4 elements, and if we change element 0, we are changing the way the insert pop-up menu looks like. And the element 1 is the delete label. Edit is the edit label, refresh, and that's it. So we have 4 built-in actions that we can enable or disable, or and change their display name. If 4 actions are not enough, we can later add custom actions. But for now, we will enable couple actions. So for this one, for example, for the pop-up names, I want to keep, I want to rename insert to like this, delete, I'm gonna rename it like this, edit like that, and so on. Then I need a way to serve, as we said, the rows. So let me go back to the wrapper or to any of the samples and examples folder in IDAPython. But I'm building it from scratch and slowly without basing my code too much on templates. So here, if I get the mandatory callback on getLine and put it here, so that's the first mandatory callback. GetLine, IDA would call us, give us a line number, 0 based line number n, and our goal is to return a list of strings. Why does it say list? Because if we have n columns and somebody asks us for a row, we have to return a list for containing all the columns. So if we want to make something completely dummy, let's also minimize the code, just like keep stuff, just calling the constructor. And for now, we're not gonna pass any meaningful data. I'm gonna hard code, always return the same to some degree. So we can say here, for line n, we have to return address, name, type in that order. So we have to return a list, and here Copilot suggested something. So the first column here is the address. Okay, remember it's a list of strings. So even if our elements are numeric, we have to return to either strings. So here, let's say the address, let's just say, for example, %x, just some um, dummy address. Name, alright, type, fine, whatever. This is good. It's gonna return synthetic lines that have dummy information. The second mandatory callback we need is how many of those lines. So let's get the size. And that should be enough for our starting chooser. We're not doing much. So here, how many elements? Okay, I don't know. Let's just say 10. That's not how we do things in real life. In real life, we'll have to find a scenario why we need to have a UI element that displays certain list of items and provides the user with actions such as select, edit, delete, whatever. So mainly if your plugin searches for stuff and wants to present the results, then the chooser is a good UI element to show that. So for now, we're hard-coding 10 elements and we're not really serving any meaningful data. Later, we can serve whatever we want. If we save this file and run it, so before we save it, we have our chooser. We need to create an instance of the chooser. So far, we called init on the chooser, we subclassed it, overrode the mandatory callbacks, and now we can create an instance, say c equal my shoes, give it a title. I'm not using the numbers yet since I hard-coded how many elements. This is not part of the actual constructor, this remnant from my previous code. So I'm clearing stuff that are not needed, keeping just the default ones. All right, that's the minimal stuff we can do here. So this should be the most basic chooser ever. Just import IDA API, extend, and so on. Let's save the file and run it. And look at our chooser. You can see here we have 10 elements, 10 of 10, and each element has just dummy name and so on. So that's the minimal chooser. Now, as you notice, that chooser has been shown non-modal, and it just got docked automatically. So I'm gonna show it. Let's say you want to show it once, you don't want it to be all the time there. So here now, yes, let's go for modal, and it will block. So the code here will not execute until the dialog is closed. So here, let's display the result. Dialog returned, and this I saved it. It runs because of IDAQ scripts, and this is a modal dialog. So I can't press anywhere unless I select. Now, if I press cancel, I get -1. So we know what happened. If I re-execute the script, press OK, notice now I picked line 6 out of 10. Now in the display, IDA shows as 1 based, but in reality, IDA internally queries as 0 based indices. Here we see some 1 based indices. So once I select an item and press OK in that case, so let's say here line 9 out of 10, press OK, here we got the 0 based selection. So I can already reason about the selection that I presented to the user. Okay, so can we get rid of this get line and make it generate something useful? Or not necessarily useful, but controllable by the user. So let's add back here n. Let's say give it 12 elements by default. And let's build this data and serve it later. So we'll serve it in getLine and build it anywhere. we can build it on init. Then we get to populate our data. We can equally populate our data from the constructor. So here we can pick any member we want to store our data for serving it back. For example, here I can say self.data equals, for example, we can make a comprehension list to compose n here let's call this I, for example, and then for I in just range n, for example. All right, so that should give us all the data we need. In case now we need to serve it, we just say return self.data of n. So data of I will give us an array that represents the whole column. So let's test this out. So all we did here, and here let's return n as well. Or we don't have to, len self.data. Now we made our information more dynamic. Now what you populate this with is up to you. All right, so we can serve pre-computed data and we can answer how much. And by default is 12. Let's construct it with, I don't know, 40 elements. All right, I'll hit save and let's take a look. So my modal chooser now has 40 elements, and those elements are generated like that using that formula. Now this could be coming from a text file, from some computation, it's up to you. All right, so that's the basic chooser. Let's experiment with other callbacks. I'm gonna add an icon per line. So right now, if you observe, we don't have icons. And by the way, if I right click, I don't have any of those default 4 actions. So let's first enable those four actions and then maybe add some icons and also change the attributes of the like background color and so on and so on. Let's go back to my Scratch code and add the actions. So here I'm gonna re-put the actions. If I get rid of if I put empty names, they will those action sorry those the pop-up names will override the names, but will not the names will not show unless there is an actual action. So just the fact that I put the pop-up names and give them names, that's not enough because there's no handler. So if I just save this and right click, I still don't see edit or delete or insert or refresh or anything. So let's just take insert or delete and bring it in and just show you how this whole thing manifests. So we can go back to kernwin, go to the callback list and grab the skeleton or prototype of the delete action. So let's take the on delete handler and paste it here. And here we have to return something. So we'll talk about returning values from certain actions. Like getLine, we know it should return something valuable, like the whole row information, get size and so on. Delete, what would the delete return really? So delete would return something to tell IDA what to do. Should I rebuild the whole list? Should I refocus the selection and so on? So we will run into this pattern a lot, and I will explain. Like we will see many callbacks, like on delete, on edit, on insert. They do say we return what has changed and what's the new selection number, what's the row number. What has changed here is hard coded 3 values we can pick from. We will see them here. So what can we return from those callbacks? We can return nothing changed, so the delete, maybe that item in our list is non-deletable. We can return to IDA kernel, telling it nothing has changed at all, so don't redraw, don't recompute, don't do anything. Hey, everything has changed. Go and go refresh, rebuild your data. That deletion invalidated everything. Rebuild the data. Or selection change, the data is still valid that we computed initially. We simply want IDA to reposition the selection after the action. So if it's a delete, we want to reposition ourselves to the previous item, for example, or maybe the next item. It depends what you want. So, so we have to return from certain callbacks with two things: what has changed, or the actual change type, all changed, nothing changed, selection changed, and the new selection index. So for the delete, well, the whole list has been changed. So here for the delete, I'm gonna implement the delete functionality. So I know we're gonna be deleting. So I'm gonna say everything will be changed, but this is tricky because if we delete the last item, what do we do in that case? Return selection -1, or if we delete the first item or the last item. So there are special cases where we have to take care of. So for now, I'm gonna just move back to the previous line. Now, for the actual deletion, indeed, I'm going to delete that row. And I'm going also to show the users that, hey, we're deleting. Now I will hit save and see how that works. So we're still running it as modal. That's great. Save. All right. And if I now hit delete or right click, I should see, because I have on delete and I overrode all the pop-up names, in particular the delete action has its callback. None of those renamed actions will show in the right click menu, but only delete, but it will show in a different caption. So here right now, right click, and I have that default action renamed from delete to whatever the user specified programmatically. So I press delete. It should now take me to the delete handler, and name 13 should be gone. So I'm gonna press delete or right click delete. I press delete. We can see here now on delete line selection equals 13. That's what I got rid of, and that's what I also got rid of from my data. Then IDA, because we returned everything has changed, IDA decides to redraw. It will first call on get size to get the new size, and then it will call get line until it gets everything. So right now, because we're returning selection -1, so here 34, if I delete it, goes back 1. But that will be problematic once I can't do -1 anymore. So as I said before, we can do better than doing cell -1 for this part here. We can use a helper function. That helper function is inside the py wraps, and that helper function is called adjust last item. We can use it, for example, as per the suggestion for on delete, on refresh, callbacks. It's super easy just to return this. And if I now change the -1, because that will eventually be problematic, especially if it's the first selection, we can now return that everything has changed, and that's basically our new selection. Either cell -1, or depending on the position, fix it correctly. So if I save this and try again, let's say now if I delete the element 0, if I didn't update the code, it will say selection -1. It will cause an exception. We'll see an exception here. So delete, it works nicely because of that helper function. So delete 29, delete 28, and so on. Now let's give those colors, or first let's give them icons. Now where do we get the icons from? It's not the topic of today, but as I said, let's see, custom icon. We do have a method called load custom icon, which gives us an icon ID. So we give it a PNG or an icon file, and or we can even give it an embedded string. It will load it for us, give us an ID. We can pass that ID to the chooser elements or to the actual chooser window itself. So since right now we're not gonna load custom icons, we'll have to make do with built-in icons. But I don't know what are the built-in indices. Like what is index 0 for, what's icon 0, what's icon 1, no idea. So we can actually write a small piece of code that can let us explore all the icons. So with respect to the icons, I'm going to get the callback for that. So we have a callback for the icons called on get icon, give us a line number. We return an icon ID. I'm going to simply return the index number. Like this, I can explore all the icons. So let's implement the whole on get icon and return n. Okay, if we save it, now we're kind of discovering icon 0. Apparently there's no icon 0, but there is icon 1, icon 2, icon 3, all the way to icon 40. But are there more? Maybe. So we know we can't have icon 1, 0. So we just have to add 1. Do we have more icons? Maybe. So let's increase this to, I don't know, 900. See if there are 900 icons in IDA. Now I made a fake chooser with 900 fake items. Can scroll down. Okay, so we started losing icons because we don't have those indices at around 216. So these are all the built-in icons. Yeah. Now let us test one more callback. We're gonna add the get attributes callback. So online on get line attributes, also given the line number, we'll have to return a tuple or not necessarily just a tuple. It could be a list. So let's experiment with that. So here we'll have to see what can we do with colors and flags. What are the options here? For colors, we have to specify the background color. So for now, I would say let's go read the documentation. So I'm gonna go to as well on getLine. Here we don't have much information for that, but I know where this comes from in reality. So getLine attributes. If you've developed the C++ counterpart, you know what you should be looking at. So here, basically, I'm looking for the actual C++ callback. So the get row was in C++ returns a lot of stuff, not just the actual line information, but in Python, we broke it into multiple callbacks. Instead of having you have a very dense callback, we broke it into multiple callbacks. So getting an icon is its own callback, getting the attribute is its own callback, and getting the actual line is its own callback. But in reality, it's a single callback. So the get row can actually return the attributes. In Python, it's a different story, but at least I know now what are the attributes. So if I follow this, the attributes I should be returning are simply the colors and flags, which basically map to that structure here, just a color, background color, and a flag. And for the flag, it says we can pass one of the ch item underscore. So we can specify bold, italic, and so on. So let's see those constants. These constants in IDAPython, they could be moved into the class or they could be at the IDAPI level. Let me double check. I'm gonna type here IDAPI dot ch item bold. Well, they're at the IDAPI level, so that's good. And that should be it for the attribute. So I should now be able to go back to my code and properly implement the getLine attribute. I'm gonna say if n modulo 2 is 0, let's return this, else return, well, this is Copilot. I'm gonna accept it and change it, of course. So we're supposed to return always the background color and the ch item attributes. So one would be, I'm gonna go for bold, and the other one, let's see what do we have for other options. I'm gonna go for italic. And for the colors are not RGB background colors, they are BGR. So that's gonna be purely blue. And I'm hoping that this should be completely red now, background color. Okay, so now if I hit save, it should hopefully each line will be bold, different color background, etc., etc. Save, and here we go. We have um, ones with BGR as we said, so it's gonna be full blue, then red. One is bold, one is italic. Let's relax it a bit. If n less than 10, otherwise we don't want to do any coloring. So here, to not do any coloring, we still have to return something. We can return the default color. The default color is FFF. That will be no color and no flags. So only for the first set of elements here, we're gonna be coloring and changing the attributes, and the rest would be nothing. And here, as you can see, we could control the icons only for certain number of elements, and then the rest we chose not to implement anything. So we have seen delete, we've seen getting line attributes, we discovered icons, how to return a line, and retrieving the data. There's one important thing I want to terminate this episode with. Why would I use choosers like this? Why don't I use Qt, for example? We'll be covering Qt on its own. But let's talk about the advantage of using built-in facilities, using IDA SDK to access UI elements. So if I go and run, instead of running ida.exe, I'm going to run the text ida. So ida.t.exe. I'm gonna pass -t just to open it with no database. And this is IDA text UI. That's the text interface. So that's ideal for automation, headless processing, stuff of that sort. So this window is too long, and hopefully can shrink it, or it doesn't want. All right. So what are the advantages of using built-in UI functionality in IDA? The advantages are the UI is portable. So you write the UI using the SDK, purely the SDK. You get to use it in IDA T, IDA Mac, IDA Linux, and so on. So this is IDA T. I'm gonna open QScripts. A QScripts itself uses a chooser to show its stuff. I'm gonna invoke our basic script that we've been using, and as you can see, this chooser is the same content. Now it might be slightly different rendering because it's a text UI, but the actions are the same. So if I right click, I can see refresh and delete, showing exactly as you want. The handlers pressing delete will delete the element. The same events on close, on everything is gonna be similar. So that's the advantage of using the built-in UI facilities. Later we'll see forms and other stuff, and we'll still be using IDA facilities. Therefore, you can have portability in the UI as well. So that's it for today. That was our first exposure to choosers. I hope you find the detailed explanation useful. Thank you very much, and see you in the next episode.